to like hold it like that here?
No, you're good. So we're going to talk about really objectives 6 through 10 here, so 4-2. We're going to talk about first construct the diagram for the quantum mechanical model of the atom. So understanding this is the current model of the atom. We just want to really briefly talk about it and then compare and contrast how is the quantum model the same or different than Bohr's model of the atom. All right, so that's kind of the point that the first slide is really going to start talking about. So let's start right here with this information right here. We have the quantum model. It's basically saying, here's the model of the atom, and it is really, the concept here is there are electron clouds or orbitals around the nucleus of the atom, and we don't really know exactly where they're at. There's a probability that the electron's somewhere in this region, okay? So that's the basic concept there for your electron cloud, the quantum mechanical model of the atom, is that we don't know exactly where they're at, somewhere around there, okay? We also want to compare that to the Bohr model of the atom. So there's the Bohr model, there's the quantum model. Compare and contrast. What are some of the similarities that you see? What's the same about the two? What do you see, Mike or Mackenzie?
They have the nucleus in the center.
Yeah, they both have a center with a nucleus, right? Where are the electrons at? They're around there somewhere, right? These have set areas where the electrons are at. So it's either here, 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 okay? It cannot be anywhere between. So if I say there's an electron there, is that okay? No, that's not okay. It can't be there. It has to be on a set path. So there, Bohr called those orbits, right? Bohr called those orbits. These regions, could an electron be here? Could it be here?
Yes.
Could it be here? Yes. Those are our orbitals, all right? There's a difference. Those are orbitals because there's no set path. Those are orbits. They're a set path, right? So that's really comparing and contrasting their Bohr's model to the current. So that was 6 and 7. 8 and 9 here, and 10, we're going to talk about now, how are these like a street address? So your address is very much different than your address, right? They're not the same street address. The only thing that you need to know from this, I'm not going to test you over Objective 8. It's to conceptualize, to understand that basically we can figure out where at in an atom these electrons are, all right? So that's for number 8. We're going to talk about, I'm going to refer to these electron configurations like street addresses so we know where electrons are at. We're going to organize the energy levels based on S, P, D, and F, so the different basic energy levels, and also how they relate to their correct shape. So you need to know the shape of an S and a P orbital, all right? So that's what we're talking about in the next 2 slides. Again, very briefly there, for quantum numbers, if you don't have that, you don't have to have that exact definition. No quantum numbers tell you where electrons are in an atom, right? It's like a street address. If you're somebody that likes a textbook definition and you want the definition of an orbital, I remember an orbital, it's an electron cloud. It's a region of space where electrons should be. There's your textbook definition of it, okay? So I'll give you a second to jot that down. But understand, right now, we just need to know how are these numbers, these quantum numbers, how do they relate to a street address of an electron, okay? So you don't have to write all this down. Don't. I just want to talk about it, all right? I want to talk about basically there's 3 quantum numbers that identify the location of an electron. So think about your street address, all right, at home. What does it start with? When you write your street address, what does it start with? Yeah, house number, right? House number's first. Then what? Street. Then
Direction.
you might put the direction, like northeast, southwest, etc. City, state, zip code, right? Well, do you actually know how that, why is it that order? Why couldn't I put the zip code first? Do you know? No, not necessarily, right? I don't even know why. That's just how it's done, right? That's how the USPS, the United States Postal Service, works, right? Their addresses. Well, we're going to learn for electrons the correct order to put them in and why it's the correct order, all right, and how to do that. So 3 of those numbers, just like your street address, house number, street name, and zip code. Zip code talks about what area you're in. Those are the 3 main quantum numbers. The last one talks about the motion of the electron. So is it what direction on the street are you going? Northwest, southwest, etc. All right? So there are your different numbers, quantum numbers. N is always talking about the energy level. So you're always dealing with energy of 1, 2, 3, 4, etc. That would be like the street number, right? They can go up or down. The shape, S, P, D, or F, that's like the street name. But remember, the shape is, instead of a road name, imagine you're on an S, P, D, or F. Those are the possible streets that you could live on. So you could live on 1S, or you could live on 2P, or you could live on 3D, etc. Alright? And each letter has a different shape, and we're going to learn those on the next slide. The orientation is like your zip code. So what area in space? You have to start thinking 3-dimensionally. All right? Am I dealing with something that's horizontal, vertical, or is it coming in and out? That's your orientation like the zip code. Now, in the other videos, you might have seen something that looks like this. Does that look familiar? Yeah? All right. The reason that it's an S, all right, and that there's one line here, okay, is due to its shape. All right, we're going to make that connection on the next slide, but I want to introduce that. P, they have 3 lines because of their shape, okay? And then the spin, up and down arrow, that's like its direction. Are you going north or are you going south as far as the electron goes, okay? So let's look at these shapes. You need to know S is a sphere, P is a dumbbell. It's like 2 balloons tied end to end. That's a dumbbell. All right? And then S, I said it's a sphere, right? It's on like, think of it as 1 dimension. I know it's a 3D shape, but no matter which way you turn it, it's never facing side to side, in and out, and up and down. It's always facing all directions at once, right? So that's why our 1S gets 1 line, or any S gets 1 line. P then, a dumbbell, think about it, in its area code, right, its zip code, I can turn it side to side, I can turn it in and out, I can turn it up and down. I can turn it 3 different ways. So I need to represent that with 3 lines. Any P is always going to have 3 lines, right? And then D, you don't have to know the shape, but this clover shape, it has 5 dimensions I can turn it on. So anytime you have a D, you're always going to have 5 lines. Because I can turn it side to side, up and down, in and out, then I can angle it left, I can angle it right. So again, I'm thinking here 3-dimensionally, I can turn this different directions. Alright? Try to conceptualize that. F, we do not need to know F, but to show you it, it's very complex. There it is, right? It's a complex shape. You don't need to know it, but it exists. Okay? Andrew, you good on that? Do you have questions? Okay? Mike,
Are there 7 for that one?
there are 7, right?
So it's 1, 2, and 5, basically.
Yeah. Alright, and again, we don't have to know that, but yeah, there's 7 different ways you can turn that shape, okay, to get it, to meet that street address.
Yeah, 1.
Alright? So, that was kind of talking about, alright, how are these organized? Well, S, P, D, and F. It goes S lowest, P, then D, then F. And these energy levels to their correct shape, S is a what? Sphere, P is a dumbbell, right? You need to know those. Alright? Next I want to get into talking about